How does enthalpy of mixing impact entropy of mixing? Imagine pouring two different liquids into a glass and watching them blend together. What really happens at the molecular level when they mix? That's where enthalpy and entropy come into play. Enthalpy of mixing is all about energy changes during the process. If mixing releases heat, it's called exothermic, and if it absorbs heat, it's endothermic. Think of it like a reaction that either gives off warmth or needs heat to happen. Entropy of mixing measures how much more disorganized or random the molecules become when they combine. Usually, when substances mix, the molecules spread out more, increasing disorder. This increase in entropy is always positive because mixing makes the system more chaotic. Now, how does the energy change, or enthalpy of mixing, influence this increase in disorder? In an ideal mixture, where enthalpy of mixing is zero, the increase in entropy is the main reason mixing happens spontaneously. The molecules just naturally want to spread out to make the system more disordered. But in real mixtures, things get more interesting. When enthalpy of mixing is negative, meaning heat is released during mixing, it actually helps the process along. The energy released makes mixing more likely to happen because it adds to the natural drive of entropy to increase. It's like the system gets a little extra push to become more disordered. On the other hand, if enthalpy of mixing is positive, meaning heat is absorbed, it can slow down or even stop mixing. The system needs to overcome this energy cost. For mixing to still be spontaneous, the entropy increase must be big enough to outweigh the heat absorbed. All of this ties into the Gibbs free energy, which tells us if mixing will happen spontaneously. The formula is simple. The change in free energy equals the enthalpy of mixing minus the temperature times the entropy of mixing. If this value is negative, mixing occurs naturally. So, in summary, enthalpy of mixing can either support or oppose the increase in entropy. When heat is released, it makes mixing easier. When heat is absorbed, it can make mixing less likely unless the entropy gain is large enough. Understanding this balance helps scientists and engineers design better mixtures, whether they're creating new materials, fuels, or solutions. It's all about how energy and disorder work together to shape the way substances blend.